The Arctic in 2017 was warmer, with less sea ice, and with continued widespread impacts on ecosystems and northern communities, reflecting an emerging new normal climate in the north. After a very warm autumn in 2016, the spring and summer air temperatures of 2017 in parts of the Arctic were relatively cool, in some ways reminiscent of conditions before the present warming trend emerged in the 1990s. These cooler temperatures contributed to a rebound in snow cover in the Eurasian Arctic, slower summer sea ice loss, and below average melt extent for the Greenland ice sheet. Yet viewed in comparison to the historical record, there are many strong signals that 2017 was typical of the warmer Arctic of the last decade. The annual average air temperature in the broader Arctic was the second warmest, after 2016, for the period since the end of the 19th century. The winter maximum sea ice extent in March was the lowest on record, and the September minimum was the 8th lowest. The sea ice cover continues to be younger and thinner than in the past. Thicker ice more than 1 year old comprised only 21% of the ice cover in 2017, compared to 45% in 1985. Sea ice more than 4 years old has nearly disappeared. Due in part to warmer than usual conditions in the Barents and Chukchi seas, autumn freeze-up was substantially delayed. In August 2017, sea surface temperatures in these regions were up to 4 degrees Celsius warmer than average. Pronounced increases in productivity at the base of the marine food web were observed in the Barents and Eurasian Arctic seas from 2003 to 2017. The tundra was substantially greener throughout the Arctic during 2015 and 2016, the most recent years with complete data. Peak tundra greenness in 2016 ranks 4th for the Arctic as a whole and 3rd for the North American Arctic. Permafrost temperatures at many observation sites were also among the warmest on record in 2016. Warming was greatest in the cold permafrost of the Alaskan and Canadian High Arctic and in Svalbard. The persistence of a new normal climate in the Arctic influences resource management for fisheries, wildfire management, and other elements of the ecosystem that directly affect the people of northern communities. Extreme conditions brought about by natural year-to-year variability of weather, on top of the warmer climate in the Arctic, impact these people disproportionately. These conditions are expected to continue beyond 2017, further pressing the need to prepare for and adapt to the new Arctic.